For the longest time, a car was a finished product. The day you drove it off the lot, that was the best it was ever going to be. But what if that wasn't true anymore? What if your car, just like your phone, could get better, faster, and smarter with a simple software update? Well, that's not science fiction anymore. It's the revolution of the software-defined vehicle.
And yeah, for years, that's been the big question, right? Your phone gets cool new features literally overnight. So why are your car's features totally locked in from day one? Well, the answer is hidden deep under the hood, in this super complex web of electronics that was just never, ever designed to evolve.
And just how complex is that web? Get this. A modern high-end car can have up to 150 separate little computers inside it. They're called electronic control units, or ECUs. Basically, think of each one as a tiny, single-task brain. You've got one for the brakes, one for the radio, one for the windows. All this hidden clutter, that's the root of the whole problem.
So here's our roadmap for today. First, we're going to untangle that hidden complexity. Then we'll dive into the software revolution that's fixing it by, completely rewiring the car. After that, we'll meet the powerful new brain that's making it all possible. Before, and this is important, we finally confront the dark side. Why your car is fast becoming a hacker's new favorite playground.
All right, let's start with the problem itself. For decades, the way automakers added new features was, well, it was simple. They just added another box, another ECU, another bunch of wires, and this created this massive electronic traffic jam that's just become completely unsustainable.
So it all boils down to this old way of thinking, this one-to-one model, where the hardware and the software for any given function were just fused together. You want heated seats? Okay, you add a dedicated ECU. A new parking sensor? Yep, that needs another one. And this meant the software was totally shackled to its specific hardware, making any kind of system-wide update pretty much impossible.
And this just creates a huge cascade of issues. I mean, with up to 150 little brains all trying to talk at once, you get communication delays. All those ECUs need miles and miles of heavy copper wiring, which adds weight and cost. It's just wildly inefficient. And maybe most importantly, it makes a simple over-the-air update, the kind your phone gets all the time, a total logistical nightmare.
But the industry is finally hitting the reset button. The solution is to stop thinking of a car as just a collection of mechanical parts and start treating it like what it's really become, a powerful, connected piece of technology. So welcome to the era of the software-defined vehicle, or SDV.
And look, the core idea here is a total game changer. It's all about decoupling the software from the hardware. In an SDV, a car's features are no longer locked into specific physical boxes. Instead, they exist as apps and services that can be updated, improved, or even added long after that car has left the factory.
And that's really the big aha moment, right? The car you buy is no longer the car you have to live with for the next 10 years. It can actually get new capabilities, anything from a more efficient engine algorithm to a brand new infotainment app, and it's all delivered wirelessly. This also opens the door for automakers to offer new features through subscriptions, which is going to change the entire business of selling cars.
But to make this software dream a reality, you first have to solve the hardware nightmare. And that means ripping up the old electronic blueprint and basically rewiring the car from the ground up. This massive shift is called the move to a zonal architecture.
And the transformation is, well, it's dramatic. On the left, you've got the old way, the domain architecture. It's a tangled mess organized by function. You've got powertrain stuff here, infotainment over there. But on the right, that's the future. The zonal architecture. It's clean, it's logical, and it's organized by physical location in the car. It is a complete rethink.
So how does this actually work? Well, instead of grouping things by what they do, a zonal architecture groups everything by where it is. A single zone controller in the front of the car manages the headlights, the front radar, and the horn. This dramatically simplifies the wiring, which makes the car lighter and cheaper to build. And most importantly, it makes centralized updates super easy and lets them add new features down the line.
Now this new, simplified body needs a seriously powerful brain to control it. The era of 150 tiny brains is over. Now it is all about one central supercomputer.
This high-performance computer, or HPC, is really the cornerstone of the whole SDV concept. It's the central computational core that does the work of dozens of those old ECUs, gathering data from all the zone controllers and making all the big, vehicle-wide decisions.
And this new brain has some serious superpowers. It's the central hub for all those continuous over-the-air updates. It manages everything from real-time safety-critical jobs like braking to processing the absolute flood of data from cameras and radar for things like adaptive cruise control. That's all part of what we call Advanced Driver Assistance Systems, or ADAS. It can even run software from lots of different companies all on one unified platform.
And it's this computational muscle of the HPC that's unlocking the future of driving, pushing us up the ladder of automation. The real leap happens at what's called Level 3, or conditional automation. This is where the car can truly take full control under specific conditions. And to do that, you absolutely need a centralized brain that can perceive, think, and act in real time.
But there's a dark side to all this connectivity. By turning our cars into these powerful, networked computers, we've also basically rolled out a welcome mat for a whole new generation of cyber threats. We've created a hacker's playground on wheels.
And this is really the unavoidable consequence. The attack surface, that's all the potential points where a hacker could try to break in, it has absolutely exploded. It's not just about physical ports anymore. It's the entire digital ecosystem that's connected to the car. And this also raises huge questions about who owns and protects the crazy amounts of data your car is now collecting.
These new entry points are, well, they're everywhere. Vulnerabilities can come from the cloud services that are pushing updates, or from the car's communication with the world around it, like traffic lights, which is called V2X, or Vehicle to Everything. Even a little piece of code from a third-party supplier could be a Trojan horse. Every single connection is now a potential risk.
And researchers, they are sounding the alarm. This quote really gets to the heart of it. The threat isn't just theoretical. It allows for attacks that can be targeted at one specific car, that are covert and hard to detect, and that are scalable enough to potentially hit an entire fleet of vehicles all at once.
And these aren't just what-ifs anymore. This is real. Researchers have already demonstrated some frightening stuff, like remotely fooling a Tesla's autopilot into seeing phantom obstacles that weren't there. In another crazy case, thieves hacked a Toyota's internal network through a connected smart speaker and just drove the car away.
Which brings us to our final and most critical question. The software-defined vehicle, it promises this incredible future where our cars constantly improve and adapt, but it comes with a profound challenge. As we hand over more and more control to complex software and connect our vehicles to the entire world, can we ever build a fortress secure enough to protect not just our data, but our very safety on the road?